Hello everyone, welcome back to this continuation of lecture tutorials on mole calculations involving solutions. Solutions means something dissolved in distilled or deionized water as the solvent. So we talk about all those things on molar concentration. Molar concentration is in mole per dm cube. This means mole per dm cube is what you call molarity or molar concentration. And this thing has a mass. This thing is mass. There are mass of hydrogen chloride. Hydrogen chloride is a molecule. In case you forget, HCl is a hydrogen chloride molecule. It's a simple covalent molecule that can dissolve in water to give you hydrochloric acid, which will be aqueous, because hydrochloric acid is a mixture of HCl dissolved in water to give you hydrochloric acid. Okay, so what do we have? We have 4 dm cube of solution. We are given mass of HCl, so the first thing you should be thinking about is the mole of HCl is going to be mass of a mR, so that is 36.5 gram divided by the mR, which is 1 plus 35.5, and it is gram per mole. That's because mR is the sum of the individual relative atomic mass as given in the periodic table. It's 1 of hydrogen, so it's 1 times 1. 35.5 is the relative atomic mass for chlorine. Relative atomic mass is defined as the average mass of the isotopes, basically all the different isotopes of the element, of that particular element. Well, it's the average mass of all the isotopes of that element relative to 1/12 the mass of an atom of carbon-12. There's your full definitions that they like to ask you in exam, I guess, because it was something I covered previously. So 36.5 divided by 36.5, I get 1 mole. So that is the mole of the HCl, and I'm going to dissolve in 4 dm cube. So the concentration of the HCl in mole per dm cube is going to be 1 mole of the HCl dissolved in 4 dm cube of the solution. Press your calculator and you'll get 0.25 mole per dm cube. If you don't like that unit, you can choose mole per dm cube like that. That is entirely fine as well. Question 2. Calculate the number of moles of solute in 250 cm cube. So in 250 cm cube of sodium hydroxide having a concentration of 2 molar, or you can pronounce it as 2 mole per dm cube solution. So we want to find the number of moles in 250 cm cube. So we know that the number of mole is equal to concentrations times volume. The concentration has to have a unit of mole per dm cube, which is the case. The volume must be in dm cube, which is not the case. Therefore, you need the conversion factor. 1 dm cube equal to 1000 cm cube. So if you have 1 cm cube, there's going to be 1 over 1000 dm cube. Because cm cube is smaller than dm cube, so 1 cm cube is 1 over 1000 dm cube. So therefore, 250 cm cube means 250 over 1000 dm cube. Do I really have to do all this on the side? Not really. I mean, this is just me showing you how to do it at this fundamental level. In reality, when you start doing this, what you do is you just get the concentration, which is 2 mole per dm cube. You multiply by the volume. The volume is given as cm cube, so I convert to dm cube by dividing by 1000. I follow the units and the maths never lie. Dm cube and the per dm cube cancel, and then I should get 2 times 250 divided by 1000, and I get 0.5 mole per dm cube. I can use either this or I can show 0.5 mole per dm cube like this. Question 3. So I have a titration. I have this unknown concentration, so presumably this is what they want me to find. I titrate HCl and NaOH. NaOH is a base, HCl is an acid. So what you have is you have an acid and base reaction. You are going to get a salt. The salt you get from hydrochloric acid is called a chloride salt. The metal salt is going to be sodium chloride. Sodium is from group 1 and a plus ion. Cl is from group 7, Cl minus ion. I said ions because it's between cations and anions. The bonding between a metallic element and a non-metallic element will give you ionic compound, and a Cl, sodium chloride, just like that. What we have then is we have the volume of sodium hydroxide. So this is sodium hydroxide you have 25.0 cm cube, but the concentration is unknown. So you don't know the concentration of sodium hydroxide, but you know the volume of the HCl. The volume of the HCl in the titration is 22.5 cm cube. And the concentration, you know, is 0.9 mole per dm cube. So they're given it in the form of mole dm minus 3, that means mole per dm cube. Like I said in the previous part, you can give your answer as this form or this form, but know that they are both the same form. I have written down the balance equation there. Base plus acid or acid plus base give you salt and water. This equation is perfectly balanced with 1 mole is to 1 mole. So we can do our mole ratio thing. Mole of NaOH over the mole of HCl is 1:1. I have 25.0. This is in cm cube. To do concentration times the concentration in mole per dm cube times the volume. The volume must be in dm cube. So I do 25.0 over 1000. That is in dm cube. Multiplied by the concentration of NaOH. This is in mole per dm cube times the volume in dm cube is going to give me the mole as the mole of NaOH. At the bottom there, based on what I've labeled here, I've decided to use the mole of HCl at the bottom. Per my label, 1 HCl. At the bottom there is the actual mole of HCl. Given the volume of solution, given the concentration of solution, these are not gases, so do not go and use molar volume of gas. This is the volume of the solution converted to dm cube. So if I just show you dm cube multiplied by 0.9 mole per dm cube, so the per dm cube and the dm cube will cancel out. That will give you the mole of the HCl that actually reacted. This is 1:1 mole ratio from the balance equation, so I can move all of these up there, and I can move the 25.0 over 1000 down there. This is just simple manipulation of mathematics, which I hope you can see. If you cannot see, however, I would suggest you to actually do it step by step. So I'll move all of these up there. This is still concentration times the 25 over 1000. So 25 over 1000 can move down there. So all of that, then 25.0 over 1000. This will give me the concentration of NaOH in mole per dm cube because of how I set up this thing on top. The volume in dm cube times the concentration. This concentration is in mole per dm cube. This volume is in dm cube, just per our usual mathematics and the formula. And I get that to be 0.81. Your answer must always have a unit, especially when it has a unit. Either you leave it like that, or you can do this. Either form will have been correct to write down the mole, the molar concentration of the sodium hydroxide solution. Question 4, so this is sodium hydroxide with sulfuric acid. So sulfuric acid is a slightly trickier acid because the mole ratio will not be 1:1 anymore. Sulfuric acid will give you a sulfate salt, Na plus, and then SO4 minus, means that I need 2 of these and 1 of these. This will give me Na2SO4. That was the reason why we did formula of ions before, and then we did balance equations before we did all this calculation. I will get water as well because this is acid, this is base. You get a neutralization to give us salt and water. I must balance my equation. I've got 2 sodium, I've got 1 sodium, so I put a 2 NaOH there. I've got 2 hydrogen, and I've got 2 hydrogen, I've got 2 oxygen. I've got 2 hydrogen and 2 extra hydrogen, so I need 2 H2O there. And the oxygen there, 2 oxygen, 2 oxygen, because we don't balance it like balance in terms of the oxygen here because we just balanced the whole unit on its own. That was what I did when I covered the lecture tutorials and a lot of work examples involving balancing the whole unit. Here you see SO4, there's 1 unit of it. Here you have 1 unit of SO4. The 2 refers to the sodium. So this equation is balanced now. What do we have to do? We are given the 25.0 cm3 of sodium hydroxide and you want the concentration of sodium hydroxide. So this is something you don't know. And then you have the acid. So you have the 22.5 cm3 of the acid. And then you have the concentration of the acid. So this is something you have. This is something you don't have. If I set up my mole equation, my mole ratio, I put the mole of NaOH on top. Simply because there's my unknown, but it really doesn't matter whether I put the NaOH on top or at the bottom because it's all about your mathematics and rearranging equation. So from the balance equation, 2 mole of these react with 1 mole of these from your own balance equation. 2 mole of NaOH reacts with 1 mole of H2SO4. So 2 is to 1. 2 mole of NaOH reacts with 1 mole of H2SO4 from the balance equation. Then I do equal to the actual. This is from the balance equation. This is actual. I want the actual concentration of NaOH. So concentration in mole per dm cube multiplied by the volume. This is in cm cube. So I must convert that to dm cube. So that is 25.0 over 1000 dm cube. Let me just make my line a bit longer. And then I have the concentration of the acid, which is 0.9 mole per dm cube. That is per dm cube. I must convert this cm cube into dm cube, divide by 1000. So what I do now is I just rearrange my equation. So be very careful about rearranging equation. This is no longer 1 over 1. So you need to multiply this whole thing by 2. So I get 2 times 0.9 times 22.5 over 1000. That is the top thing. All of these multiply to the 2. And then I move this 25.0 over 1000 to the bottom. So that's 25.0 over 1000. If you can't do this in one step, I would suggest you to actually break it down and show your working in 2 steps. But ideally speaking, you should be able to do this eventually in 1 step. So I'll just write down mole per dm cube like this. Of course, your alternative answer will be the units in the other type of form, in the mole dm minus 3 form. And there's concentration, there's molar concentration. Moving on to the next question. So we have calcium hydroxide. Calcium hydroxide is also lime water. A saturated solution of calcium hydroxide is lime water and react with hydrochloric acid. So if I have the hydroxide plus the acid, I will get salt, I will get chloride salt, I'll get calcium chloride salt. Calcium is group 2, so it's from calcium 2 plus ion, Cl minus because it's a group 7 element, so it forms a Cl minus ion, metal and non-metal ionic bond, giant ionic structure, calcium 2 plus Cl minus, you will have CaCl2, you will have water as the byproduct because this is neutralization between an acid and a base. You have 2 chlorine there, so I need 2 HCl. If I have 2H and another 2H, I need 2 H2O because they will give me 4 hydrogen, 2 from there, 2 from there, and 2 oxygen will give me the 2 oxygen. This equation is balanced now, so I need the concentration of calcium hydroxide. I have the concentration of HCl and I have the volume of HCl, so I need to set up my equation. The mole of the calcium hydroxide is to the mole of the HCl. From the balance equation, my balance equation shows 1 mole of calcium hydroxide. So 1 mole of calcium hydroxide reacts with 2 mole of HCl. I follow my label, what I have written down very, very clearly. And then on the right hand side is my actual number of mole of calcium hydroxide and the actual mole of HCl. My concentration of calcium hydroxide is unknown. Multiply, that is in mole per dm cube, multiply by the volume of calcium hydroxide, which is 25.0 cm cube. So convert that to dm cube. And at the bottom is the actual mole of HCl, so there's 0.08 mole per dm cube, multiplied by the volume of the HCl, which is 35.0 over 1000 to convert that to dm cube. So concentration of calcium hydroxide is going to be 0.08 times 35.0 over 1000 divided by 2, because all of these you move up there is multiplied by 1, but the 2 at the bottom is still there, so it's divided by 2, and then I move the 25.0 over 1000 down there, so that is 2 multiplied by 25.0 over 1000. Be very careful about your cross multiplication and your mathematics, your bookkeeping essentially. So one wrong bookkeeping would mean that you mess up your whole calculation. I get 0.056. That doesn't mean anything unless I put down the units. As I said, you could also use the alternative unit form, which is mole per dm cube. Just know that they are the same and stick with whichever one you're happy with. Question 6 is the last bit on this work example series accompanying the solutions mole calculation. So we have anhydrous sodium carbonate. Anhydrous means no water of crystallization. So you would have heard of water crystallization a few lecture tutorial ago when we dealt with empirical formula. You have seen it in the practical classes as well. So what we have is sodium carbonate. Sodium is Na+, sodium ion is Na+, carbonate ion is that. So you just do the cross multiply where you bring down the value of the charges. The value of the charge there is 2, so it's 2. This means 2 of the Na+ and 1 of the CO3 2-. You get Na2CO3 as the formula for sodium carbonate plus HCl. So this is another classic reaction. Metal carbonate plus acid will give you metal salt. The salt from hydrochloric acid is chloride, so you get a sodium chloride, which is Na plus Cl minus. You also get carbon dioxide and water because this is a metal carbonate reacting with acid. This accompanies what you have seen as a test for carbonate in the qualitative analysis part of the course, where it will react with any acid to give you the CO2 gas. This equation is not balanced. 2 Na there, I need 2 NaCl, and then 2 Cl there, I need 2 HCl. Then I have 2H, CO3 give me CO2, 1 of the oxygen goes there. This equation is now balanced. This is the first time you have seen it where you are given the masses. So this is a mass, but you have information on this because you can work out the MR. So you can have the MR, you have the mass, you can work out the mole of Na2CO3. You know the concentration of the acid, but you don't know the volume of the acid required to neutralize all of the sodium carbonate. So let's work out the MR of Na2CO3 first from your periodic table. So there's 23 for 1 sodium, and I have 2 sodium, so 23 times 2 plus 12 times 1 plus 16 times 3, and pop that into your calculator. And I get 106. Don't forget that there is gram per mole. So my second step will be my mole ratio. So I'll put the mole of HCl on top and then the mole of Na2CO3 at the bottom. Again, does it matter if it's the other way around? It does not, as long as you know how to do the math correctly and follow the ratio. From the balance equation, I have put HCl on top. So from the balance equation, I have 2 HCl. So it's 2 HCl reacting with 1 sodium carbonate. On the right hand side will be my actual mole of HCl that reacted. So I wanted the I have the concentration of the acid, which is 0.25 mole per dm cube. And I will multiply by the volume of the HCl divided by 1000, because that volume will give me, that volume is actually in cm cube. When I do that, divide by 1000, I convert the volume in cm cube to dm cube. So my answer when I get volume of HCl later on will be in terms of cm cube. If you don't like this method, what I would say is you can always just write this down. You can just say V. But what is V? V, you can make it into dm cube, then it will make your life easy, and you can convert it to cm cube later on if you want to, because something per dm cube times dm cube give you mole. So this volume is now, as I define it from this equation, is the volume of HCl in dm cube. And then at the bottom, I have the mass of the sodium carbonate. So I'm given the mass. So mass over the MR, which is 106 gram per mole. So the gram cancel out. So what we will get, if I have enough space, I think I do, is volume is equal to 2 times 5.3 over 106. That is on top. And then at the bottom, I'll bring down the 0.25 and the 1 down there. Okay, so the next step, just rounding up the very last bit, volume is equal to 2 times 5.3 divided by 106 and then divided by 0.25. I get volume equal to 0.4. The units are very important. This is 0.4 dm cube. See if I can write that a lot better. 0.4 dm cube. Do not forget that 1 dm cube equal to 1000 cm cube. So I can convert the dm cube to cm cube by multiplying this by 1000 if I want to, and then I will get volume is equal to 400 cm cube. So they haven't mentioned to us whether we will need cm cube or dm cube volume. So you could have left your answer as, you could have left your answer in dm cube. You could also have left your answer in cm cube. It doesn't matter because they mean the same thing based on this conversion factor. So that's it really on these 6 questions involving work examples on how we manipulate concentration of solution multiplied by the volume of solution in dm cube, and how we could relate to mole ratio from the balanced chemical equation before we actually start off on a correct path for calculations involving mole. And of course, that calculation involving mole can involve solid, it can also involve gases as well. So that's it for this lecture tutorial. As I said, follow me at ptet.chemistry on Instagram, Facebook and Twitter to get connected, and don't forget to click the button on the bottom right to subscribe to the channel if you have enjoyed my tutorial videos, and share the channel widely with all your friends, chat group, relative, juniors and seniors from school, whomever you think the channel or the videos on my channel will be useful for. Thank you for watching. See you in the next lecture tutorial.